here's the final lesson of the week, lesson 71, trinomials with common factors in subscripted variables. This is my last of 15 videos that I've done this week. So hopefully you've watched all of them. If you watch this, stay tuned, I have something to tell you in a little bit. Okay, anyway, we're going to factor these. Remember we factored trinomials a couple lessons ago. How long ago was that? That was in lesson 69. So we haven't had a class time to talk about these, so hopefully doing this will help you and not confuse you. We're going to factor a trinomial. Now, when we factored trinomials, we made two sets of parentheses. So we go like this, and like that, and then we try to figure out what times what gives you the first term. But before we do that, there's another step that you should do. You should look at each term in the trinomial and see if there's anything common that you can factor out of it. Anytime it says to factor, the first thing you should always do is look for a common factor. So look, what's common between all these terms? There's an x common. So we want to take the x out before we start doing our trinomial factoring. So if we take an x from x cubed, we get x squared. Take an x out of x, 6x to the second, we get 6x. Take an x out of last term and we get 5. Now we're ready to do trinomial factors. So we do our two sets of parentheses, and we say what times what gives me x squared, so that'd be x times x. What times what gives me 5, and when I add them, look at the last sign, when I add them I get 6. So we have 5 times 1 is only factors. So we put 5 and 1. You look at the last sign. The last sign's positive, so they're both going to be the same. What are they both going to be? You look at the next sign, they're both going to be plus. You should always check these. The first would be x squared, outer is 1x, inner is 5x, that adds up to 6x, and the last is 5. That's all there is to these. So to get a little bit harder, look at example 2. We're going to look to see what's common in all of these. We see that there's a b in all of these, an x in all of these, and it looks like a 4 can divide into all of these. So we're going to take all of those out, our first step. So we're going to take out a 4, b, x. And in the first term, we're just left with an x squared. The second term, just an x. And the third term, if we divide 4 into that, we get 20, and we're taking both the b and the x out. And now we're ready for trinomial factoring. So we have 4, bx. We do two sets of parentheses. Look at the last sign. It's negative, so that tells us one's going to be a plus, one's going to be minus. If the last sign's negative, the signs are different. Then we start what times what gives me x squared, x times x. What times what gives me 20, and when I subtract them, I get negative 1. Well, we would have 1 times 20, 2 times 10, and 4 times 5. The only two that you subtract and get to get 1 would be 4 and 5. You want it to be negative, so you make the bigger number negative and the smaller number positive. Check your outer is negative 5x. Always check your outer and your inner, and make sure you get your middle term, which we did. Alright, next one's a little bit more complicated. This one, it almost looks like there's nothing you can factor out, but we don't want to start with a negative number there. So what we're going to do first is we're going to factor out a negative 1. Factoring it out is going to change all the signs. So if I take out a negative 1, I would say what times negative 1 gives me negative x squared, and that would be x squared. When you're factoring out, it's the same as dividing. So if I'm going to divide this by negative 1, I'm going to get a negative x. And if I divide 20 by negative 1, I get a negative 20. Now, whenever you factor out a negative, just remember this changed from negative to positive, positive to negative, positive to negative. Now, keep that negative 1 out there. Make two sets of parentheses. What times what gives me x squared? What times what gives me 20? And when I subtract them, see, this means the signs are going to be different. When I subtract them, I'm going to get negative 1. So we're going to get, that would be 5 times 4, right? Gives us 20, and when I subtract them, it would give us negative 1. So put the bigger one with the negative, because we want it to end up negative, smaller one with the positive. or you can say negative 5 times positive 4. And that's all there is to that. Last example before you try them. This one looks a little bit more complicated because of the 72 and the negative sign. So we definitely want to factor out the negative, and this time we're going to factor out a 3. So it would be a negative 3 instead of a negative 1. So we're going to get x squared plus, remember the sign's going to change because we're factoring out a negative, 2x minus, and if I divide 3 into 72, I'm going to get 24. Now notice I took out a negative, and so all the signs changed. Now it's trinomial factoring. What times what gives me x squared? It'd be x times x. What times what gives me 24, and when I subtract them, remember one sign's plus, one sign's negative, the bigger number goes with the plus because we want it to end up positive. So we could do 2 times 12, but when we subtract them we don't get 2. We could do 8 times 4. When we subtract them we can't get 2. And finally we can do 4 times 6. When we subtract them we do get 2. We want it to be positive, so the bigger number has to be positive, the smaller number negative. Okay, go ahead and try number 1. Pause the video and give it a try, and then turn it back on and see if you got it right. Okay, let's see if you got it right. I'm looking what's common, the 2. Take that out. So as I said, when you factor it out, it's the same as dividing. So we're going to divide by 2, take it out, we should get x squared plus 5x plus 6. You can see if we put this back in, we would get what we started with. If we multiplied this through, we would get what we started with. So it's the opposite of multiplication. We're dividing out is what happens when we're factoring. So we take and we do our trinomial factors. What times what gives me x squared? What times what gives me 6? And when I add them, I get 5. First of all, we know both signs are going to be plus because the last sign says they're both going to be the same. What are they going to be? They're going to be whatever the first sign is. If we were to multiply these all back through, we should get what we started with. So let's just try it. 2 times first x squared, outer is 2x, inner is 3x, that's 5x, and this would be 6. And then if we distribute it, 2x squared plus 10x plus 12. And we get what we started with, and that's the goal. Right here is your answer though, if you're going to factor it. Remember, factors can be multiplied together to get what you start with. Okay, go ahead and try example 2. I'll just leave that one so you can see it. Okay, this is the tricky kind where you have a negative sign, so let's take out the negative. And we also have a b in all of them, so I'm going to take out a negative b. All the signs change. That becomes positive to minus, negative, so we get 5b, and we get plus, actually, we're taking out a negative so it changes, and we get 24. Negative b, this looks like a tough one, b and b, let's see, we would have 2 and 12, no, they don't add together to get me 5. Or they would subtract. I'm looking at the wrong one. They would subtract. One sign would be positive, one sign would be negative. If the last sign is negative, the signs are different. 2 and 12, we get 3 and 8. If I subtract 3 and 8, do I get 5? Yes. Which one should be negative? Well, we want a negative answer, so the bigger one has to be negative. Check your outer and inner. Your outer is negative 8b. Your inner is 3b. Add those up, and you get the middle term, which is negative 5b. Okay, this lesson has 2 parts, so let's move on from that part to subscripted variables. I was saying in the beginning, hopefully you're watching this video. If you are, send me an email that says that you watched the video, and I will give you extra credit. Okay, subscripted variables. Now this is a system of linear equations, and we could solve these either by substitution or elimination. Now sometimes we want to be more specific with our variables. Instead of just using x and y, we want to use descriptive variables. Like if we're going to do coin problems, we're talking about nickels and dimes. Instead of putting X, we might want to say nickels, N. Or dimes, we might say dimes. We can be even more specific. We could write this as 5 number of nickels, and that's called our subscript right there, plus 10 number of dimes equals 125. We're going to be doing coin problems shortly, and we're going to be using subscripted variables so that when we look at our equations, we know what the variables stand for. So all we're doing here is replacing our x's with number of nickels, or n sub n, and our y's with number of dimes, or n sub d. We say these n sub d. That's how we talk about our subscripted variables. Our second one, if we replace the x with n sub d, we would just get n sub n, plus replace the y with n sub d, we get 16. I might not have left enough room for this. Let's do this one. You have to follow the directions and how they tell us to solve it. This one says to solve by elimination. So we need to multiply this bottom equation by something so that when we add it to the top equation, one of the variables adds out. So I'm going to stick with the easier one. I'm going to multiply the bottom row by negative 5. Let's see if I can squeeze this in over here. So we're going to get, the top one stays the same, plus 10 n sub d equals 125. The bottom one we're going to multiply by negative 5. As long as you multiply every term in an equation, it doesn't change the equation. It's totally legal. So we're going to get minus 5 n sub n minus 5 n sub d equals minus 80. So we're just distributing this 5 across the board here. And now we have a plus 5n sub n, and a minus 5n sub n. So we do eliminate a variable, and we get 5n sub d equals 125 minus 80 gives us 45. Divide both sides by 5, and we get the number of dimes equals 9. Then we can go back up and find the number of nickels. So we go up into this equation right here. We have the number of nickels. Substitute n sub d equals 9 equals 16. N sub n equals 7. And those are your two answers. So these are still just like we did before with systems of equations, but we're using, instead of just simple x and y, we're using subscripts. And that can make it seem a lot harder than it is. Let's try one more. We're going to do this one by substitution. Eventually they won't tell you which method to use. You're going to have to choose. And you can see this one's already solved for n sub q, so substitution does make a lot of sense. So n sub q would be number of quarters. So it's 5 number of nickels plus 25 number of quarters equals 290. Number of quarters equals the number of nickels plus 2. So here we go. We're going to substitute the n sub q. We're going to set what it's equal to, and we're going to put it in for where the n sub q is. So we get 5 number of nickels plus 25 times n sub n plus 2 equals 290. We distribute 5 number of nickels plus 25 number of nickels plus 50 equals 290. Add our n sub n because they're like terms together. We get 30 n sub n number of nickels, and I can just subtract this 50 from both sides while I'm at it, equals 240. Divide both sides by 30. We get our number of nickels equals, these cross out, equals 8. And then all we have to do is go back and get our number of quarters. So we can go right into that equation. So our number of quarters equals our number of nickels, which is 8 plus 2. So our number of quarters equals 10. Okay, hopefully that made sense to you, and we'll see you tomorrow, Friday, in math class.